This e-commerce page has 12 product listings, names, prices, images. But when I fetch it with Python, every single field comes back empty. 12 product cards and every one of them is blank. Well, that's because the product page gets loaded by JavaScript after the page loads, and a basic HTTP request can't run JavaScript. So you get the page structure, but none of the actual data. In this video, I'm going to show you 4 different ways to fix this. We'll start with getting the full rendered HTML using Python. Then we'll extract structured JSON using CSS selectors in JavaScript. Then we'll grab clean markdown and links without writing any selectors at all. And finally, we'll break through bot detection on a site that actively tries to block scrapers. You won't need to install or manage a single browser for any of this, so let's get into it. So what is web scraping? It's really simple. Web scraping is when you write code to automatically pull data from websites. Instead of sitting there copying product names and prices into a spreadsheet by hand, you let a script do it for you. The most common use cases you'll run into are price monitoring, where you're tracking what competitors charge on e-commerce sites. Then there's market research, where you're pulling data from dozens of sources to spot trends. There's also lead generation to get new clients, and content aggregation, where you're combining information from multiple sites into one place. Now, there's a quick distinction worth knowing. Data scraping is actually the broader term. It covers pulling data from databases, files, APIs, basically anything. Web scraping is specifically about pulling data from websites. That's what we're covering today. And one rule before we dive in. If a site has an official API, I recommend you use that instead. APIs give you clean, structured data that won't break when the site changes its layout. Scraping is most useful when there's no API available, or the API doesn't give you what you need. Here's the core problem you need to understand. When you visit a website in your browser, the browser does a ton of work behind the scenes. It downloads HTML, runs all the JavaScript, makes API calls to fetch data, and renders the final page you actually see. But when your Python or JavaScript snippet are making HTTP requests, all it gets back is the raw HTML. No JavaScript actually runs. No API calls happen, nothing gets rendered. For static websites, that's totally fine. The server sends you a complete HTML with all the data baked right in. But most modern websites don't work like that anymore. Since these sites are built with React, Vue, or Angular, they send you a minimal HTML shell first. Then JavaScript fills in all the content after the page loads. So when your script fetches that page, you get the empty shell, but none of the data. Let me show you exactly what that looks like. Here's a Python script using request and beautiful soup, which is probably the most common scraping setup out there. I'm hitting an e-commerce page that has 12 product listings. Each product has a name, a price, and an image. The code is really straightforward. I fetch the page with request.get, parse the HTML with beautiful soup, and try to pull out the product name, price, and the image from each card. Let's run it and see what happens. It found 12 cards in the HTML, but look at the actual data. It's all empty. None of it was found. The HTML has 12 product containers, but they're all just empty shells. The real data gets filled in by JavaScript after the page loads, and the request library simply cannot run JavaScript. This is the #1 problem beginners run into with web scraping. The page looks perfect in your browser, but your script gets absolutely nothing. Okay, so how do we fix this? We need something that actually renders the page, something that runs the JavaScript, waits for the data to load, and then gives us the final HTML with everything filled in. That's what a headless browser does. It's a real browser that runs without a visible window. But managing headless browsers on your own is a whole other headache. You've got memory leaks to deal with, scaling issues, and infrastructure you have to maintain. It gets complicated fast. So instead, I'm going to use Browserless. Browserless runs headless browsers in the cloud and gives you a simple HTTP endpoint to work with. You don't install anything. You don't manage any infrastructure. You can just make API calls. The first endpoint we'll look at is called content. You send it a URL and it loads that page in a real browser, executes all the JavaScript, and sends back the fully rendered HTML. Now let's open up our code again. I'll switch to this other code, which is almost identical to the broken version. The only real change here is that instead of request.get going directly to the page, I'm doing request.post to the Browserless content endpoint. I pass in the URL I want to scrape, along with a token and a wait for selector option, which tells Browserless to hold off on returning the HTML until the product names have actually appeared on the page. Everything else is exactly the same. Same beautiful soup parsing, same CSS selectors. The only thing that changed is where the HTML comes from. Okay, so let's run it. It worked. Now we have all the data on the 12 products fully loaded with names, prices, and image URLs. What happened is the content endpoint loaded the page in a real browser in the Browserless cloud and waited for the JavaScript to fill in all the product data and then sent back the complete HTML. After that, Beautiful Soup just parses it the same way it always does. And if you use Scrapey or Cheerio, it's the exact same flow. You just override your start request method to call the content endpoint instead of fetching the page directly. The rest of your spider stays exactly the same. I'll link the Scrapey and Cheerio docs in the description. So the content endpoint gives you the full rendered HTML, and then you parse it yourself with whatever library you prefer, be that Beautiful Soup, Scrapey, or Cheerio. But what if you don't want to deal with parsing HTML at all? What if you could just tell the API, give me the product names and prices, and get back with a clean structured JSON with no parsing library step? Well, Browserless actually has an endpoint for exactly that. Let me switch over to JavaScript and show you how it works. This is the scrape endpoint. Instead of getting the full HTML and writing your own parsing code, you just tell Browserless which elements you want by passing in CSS selectors, and it gives you back structured JSON. Here's the code. I'm targeting the same e-commerce site from earlier, but this time I'm using the scrape endpoint instead of content. I've defined 3 CSS selectors that I want. .product name grabs the product names, .price grabs the prices, and .product image grabs the images. That's the whole request. No Beautiful Soup, no parsing libraries at all. You send in selectors and you get back JSON. Let's run it. There you go, 16 products, all structured as JSON. Each selector comes back with an array of matches. So the big difference from content is that you're not getting the raw HTML and writing your own parsing logic. The scrape endpoint handles the extraction for you. You tell it what you want and it gives you clean structured data. This is perfect for something like a price monitoring cron job. You hit the endpoint on a schedule, pipe the JSON into a database, and you've got automated price tracking running in production. But notice that you still need to know the CSS selectors ahead of time. What if you just want to grab the content from a page without having to inspect the DOM first? That's when the smart scrape endpoint comes in handy. Maybe you're building a pipeline that feeds page content into an AI model. Maybe you're scraping a bunch of different sites and writing custom selectors for each one, and that's just not realistic. Or maybe you just want a quick look on what's on a page before you decide how to scrape it properly. That's what Smart Scrape is for. You give it a URL and tell it what formats you want back. HTML, Markdown, links, even a screenshot or a PDF. And it figures out the best way to get it. Here's the code. I'm pointing it at Hacker News and asking for 3 formats: Markdown, links, and the raw HTML. That's the entire request. No selectors, no extra configuration. Now, here's the interesting part. Under the hood, Smart Scrape uses a cascading strategy. It starts with a fast, lightweight option and incrementally uses tougher solutions. It can even lead up to solving a CAPTCHA. You don't have to configure any of this. It just picks the fastest approach that actually works. Let's run it. Cool, look at the response. The strategy field says HTTP fetch, which is the lightest and fastest approach. That makes sense because Hacker News doesn't block automated requests and just serves all the data from the server end. So it didn't need to escalate to anything heavier. On a trickier site, you'd see it automatically step up to a proxy or a full browser. And look at the actual data. Clean Markdown with all the Hacker News post titles and discussions, a full array of every link on the page. If you're feeding this into an LLM or a search index, this output is basically ready to use since Markdown is very lightweight compared to full HTML. No parsing needed, no selectors needed, no cleanup. It just works on autopilot. Now, the Smart Scrape endpoint already handles bot detection and CAPTCHAs for you, but it gives you back data and that's it. What if you need to actually stay on the browser after getting past the defenses? Navigate around, interact with elements, scrape data that only shows up after clicks, or you need to log in? That's what the unblock endpoint is for. It has the same stealth pipeline, but it also returns a browser WebSocket endpoint. That's a live WebSocket URL that you can hand to Puppeteer or Playwright to connect to, and then you can continue your automation with those libraries. Here's the code. If I try to fetch data from StockX with the content endpoint, I'll get bot blocked. But if I request it through unblock, that site will be unblocked, and then I'll get back the WebSocket endpoint. So I can use that to connect with Puppeteer and then scrape the product name, price directly from the live page using selectors. Let's run it. Browserless got us past Cloudflare, and Puppeteer pulled the data out of a real unblocked browser session. So the Smart Scrape endpoint gives you data, and the unblock endpoint gives you data plus a browser you can keep using. All right, let's do a quick recap. You've got 4 endpoints, and each one fits a different situation. Content gives you the full rendered HTML so you can parse it yourself. This is the best fit for Python developers who already use Beautiful Soup, Scrapey, or Cheerio because your existing code barely changes. The Scrape endpoint takes CSS selectors and gives you back structured JSON. No parsing library needed. That's really good for automated pipelines and cron jobs where you know exactly what data you want. The Smart Scrape endpoint gives you clean markdown, links, screenshots, PDFs without needing any selector. It automatically picks the fastest strategy that works, so it's perfect for feeding data into AI models or building content pipelines. You can even use an MCP with Smart Scrape to get data with an LLM. And the unblock endpoint is for when a site actively blocks you with bot detection. It handles basic stealth features and fingerprint protection behind the scenes, and it allows you to reconnect to that browser with a library such as Puppeteer or Playwright to continue automation after unblocking the site. Now, there are situations where even these aren't enough. If you need multi-step workflows like logging into a site, clicking through a few pages and then scraping, or if you're up against really advanced anti-bot systems that need fine-grained browser control, CAPTCHA solving, then Browserless has something called BrowserQL. It lets you build an entire browser interaction flow in a single REST API query. But that's a whole separate topic, and we'll cover it in a separate video. You can find the link to that video in the description below. A few quick best practices before you go. Stick to publicly available data so you don't break terms of service on sites. Don't hammer sites with thousands of requests per second because you'll end up DDoSing them, and that's not a very sustainable way to ethically scrape online. Always check the site's terms of service before scraping, and always prefer an official API when one exists. Browserless has a free plan that doesn't require a credit card, so you can try everything I showed you today right now. All the code and links to the documentation are in the description below. Thank you for watching, and I'll see you on the next one.